we are going to discuss hybridization of various organic molecules such as alkane, alkene and then alkynes. In addition to that, we can also find the hybridization of various functional groups such as aldehyde, ketone, alcohol, amine, etc. We are well known about that organic chemistry. It only deals with the compounds made by carbon atoms. The atomic number of carbon is 6. The electronic configuration is 1s2, 2s2, 2p2. So it contains only 2 number of unpaired electron. By actually speaking, carbon create or generate 2 number of chemical bonds, but it generate 4 number of chemical bonds. To make 4 number of chemical bonds, carbon would have to decouple its 2s electrons onto the 2p orbital. In the year of 1931, the chemist Linus Pauling proposed a concept by the mixing of atomic orbitals resulting with the generation of new identical orbitals, that is known as the hybrid orbitals. Here we note that the number of hybrid orbitals generated is equal to the number of atomic orbitals involving into the hybridization. The character of the generated hybrid orbital, and that is whether it contains how much amount of s character and how much amount of p character, it only depends on the number of s orbitals and number of p orbitals involved in the hybridization process. The s orbital is in spherical shape and p orbital is in dumbbell shape. The p orbitals px, py and pz present in the x, y, z axis. The atomic orbitals are at 90 degree to each other, whereas the VS EPR theory predicts the 3D structure of methane. Methane exists in tetragonal shape with bond angle 109.5 degree. So how we can get this 109.5 degree from 90 degree atomic orbitals? It's all about hybridization process. Next, we discuss sp3 hybridization. By mixing of an s orbital with 3 number of p orbital, it gives 4 sp3 orbitals. The generated 4 number of sp3 orbitals are identical to each other with same energy. According to the VSEPR theory, those orbitals needed to be as symmetric. It was only achieved by tetrahedral shape with bond angle around 109.5 degree. When those hybrid orbitals make chemical bonds with some other atoms like hydrogen, we get molecular orbitals oriented in the same direction. Next, sp2 hybridization. By mixing of 1 s orbital and 2 number of p orbital, we can get 3 number of sp2 hybridized orbitals which are identical to each other. The 3 sp2 hybridized orbitals are exist in trigonal planar geometry with bond angle 120 degree around central atom. The unhybridized pz orbital present perpendicular to the trigonal plane, which can make a pi bond with neighboring groups. In sp hybridization, 1 number of s orbital and 1 number of p orbital are mixed together to make hybrid orbitals. Here 2 number of p orbitals such as p, y and p, z do not take part in the hybridization. The generated new sp hybridized orbitals exist in the linear manner with bond angle around 180 degree, and the unused orbitals can make 2 number of pi bonds with other orbitals. Next, I can suggest one of the easiest way to predict the hybridization of some of the molecules. It only based on the groups attached to the central atom. If a central atom connected with 4 number of groups, it has sp3 hybridization, whereas central atom connected to the 3 number of groups, it has sp2 hybridization, whereas the central atom connected with 2 number of groups, it has sp hybridization. In addition to that, lone pair electrons present in the heteroatoms like oxygen and sulfur also considered as a group for assigning the hybridization of molecules. Let we see some of the examples. In ethane, the highlighted carbon connected with 3 number of hydrogen atoms and 1 number of methyl group. So the total number of groups is 4. So the highlighted carbon has sp3 hybridization. In 2-methyl-1-propene, the highlighted carbon connected with 2 number of methyl group through single bond and 1 number of methylene group through double bond. So the highlighted carbon connected with 3 number of groups, hence the hybridization is sp2 hybridization. In 1-propane, the highlighted carbon connected with 1 CH3 group through single bond and 1 CH group through triple bond. Hence the connected group is 2. So the hybridization of highlighted carbon is sp hybridization. In dimethyl ether, the heteroatom is oxygen. It connected with 2 number of methyl groups, and also the oxygen contain 2 number of lone pair electron. So here the oxygen connected with 2 methyl group and it contain 2 number of lone pair electron. So the total group is 4. So the hybridization of highlighted oxygen is sp3 hybridization. In acetone, the heteroatom oxygen connected to the carbon through double bond and also it contain 2 number of lone pair electron. So the total number of groups here is 3. Hence the highlighted oxygen atom present in sp2 hybridization. In methanol, the highlighted oxygen connected with 1 number of hydrogen atom and 1 number of methyl group, and also it contain 2 number of lone pair electron. Hence the total number of group is 4. So the hybridization of highlighted oxygen is sp3 hybridization. In trimethylamine, the heteroatom nitrogen connected to 3 number of methyl group through single bond, and also it contain 1 number of lone pair electron. Hence the total number of groups here is 4. So the nitrogen present in sp3 hybridization. In acetonitrile, and that is CH3 C triple bond N, the highlighted heteroatom nitrogen connected to the carbon through triple bond, and also it contain 1 number of lone pair electron. Hence here the total number of groups is 2. So the highlighted nitrogen present in sp hybridization.